Okay, this is Exponents, Lesson 11, and it's talking about scientific notation. So we use scientific notation with integral exponents, meaning positive and negative exponents. We use it for very large numbers or very small numbers. So we're going to take a look at what happens with large numbers in scientific notation. So it says the distance of the Earth to the Sun is approximately 93 million miles. The speed of light is approximately 300 million meters per second. The number of molecules of gas per meter cubed is approximately, oh my gosh, millions, billions, trillions, quadrillions, 27 quintillion. So those are very large numbers. If we were to write that standard notation, so this is called standard form, as we know. Okay, standard notation. Notation is a funky word to say form. And all it means is the answer. Okay, so that's our standard form, standard notation. That's just your answer. So what we need to do is convert them to powers of 10. So all those zeros are just going to be times 10 to the exponent, however many zeros you have. So if I want to create anything in scientific notation, we do it for numbers too small or too large. So what we have to do, here is the basic idea of it. It's going to look like this, a times 10 to the n. Now the letter A, that's your digit. The digit has to be between 1 and 9. Here it says 1 and 10, but it says less than 10. This means, that's a funky way of saying the number is between 1 and 9. And yes, it can be a 9. It can't be a 10. It can't be 10 because 10 is 2 digits. So it's got to be a single digit. Okay, it's got to be a single digit on the left of the decimal. And that number cannot be a 0. Okay, that's a big hint here. That digit can never be 0. Okay, so that digit can never be a 0. We're going to get lots of numbers that say 0.000, and that's where we're going to turn those into scientific notation as well. So if we've got standard form, standard notation, that's our answer with all the zeros on it. Yep. You betcha. Okay, so standard notation. Expanded form means write it out with all of your base 10s. So this guy here, first of all, what you want to do is you want to locate where the decimal is going to go. The decimal is going to go through between your first 2 digits. So I know my number is going to be a 6.15. Now, how many 10s do I have to multiply it by? You multiply it by the number of 10s as there are digits after that decimal. So right now you see 4 digits after that decimal. That means you're going to multiply it by 4 10s. Yeah, exactly. Exactly. So then this becomes 6.15 times 10. And now you've got how many 10s? You've got 4 of them. And again, that number here, this number matches the number of digits after your decimal, always. Okay, and yes, it includes those zeros because those zeros are a times 10. So the next number, where would I put my decimal point? Where's the decimal point going to go? In front of the 5 or behind the 5? Behind it. It's going to go right there. So this guy's going to be 5.0. Yes, you have to show the 0.0. Now, how many 10s am I going to have on there? How many digits are after the 5? 5, right? I have 5 digits after the 5. They're all zeros, so I'm going to have 5 10s. And then that makes my number 5.0 times 10 exponent 5. All right, next question. The decimal's in the wrong spot. Where do I have to move the decimal? Behind the 4. Good. So he's got to move right there. So this is going to be 4.63. Now, how many digits are going to be after the decimal now when I've moved it? 2 digits after the decimal. So that means I'm timesing by 10 twice. Or sorry, you're only going to times by 10 once here because you're only moving it to where the decimal started. So what I'm going to show you here, if I were to blow this up, every one of these numbers has a hiding decimal. What we've done is we've moved that decimal to a new spot. This guy had a hiding decimal. He moved to right there. This guy didn't have a hiding decimal. So if you see the decimal, you're only timesing it by tens till you get to the decimal. Okay? So how many spaces did I have to move it? I had to move it one space to get to where the decimal originated. So that means I'm only going to have 110. Okay? It's because of what the number started as. So this guy's going to be 4.63 times 10 exponent 1. And no, you don't have to show the 1. Now, the next number, it wants us to work backwards. So it's giving us the expanded form. So what would my notation look like? What do you think my number would look like? Well, when you're timesing by 10, that's the same thing as literally multiplying by 10 in your calculator. So if you wanted to do it longhand, you would take your calculator and you would type in 2.81 times 10 twice. And it'll do it for you. And it just moves your decimals. So you're going to get 281. So what has actually happened? When you multiply by powers of 10, you move your decimal to the right. Okay? So the decimal moves to the right when you multiply by powers of 10. So what way do you think the decimals going to do when you multiply by powers of 10 when it's a negative? It's going to go left. Okay? So when you're going right, it'll be a positive. So here I had to move it 2 places. So that's what's happening. I get the number 281. All right, let's take our scientific notation. I have the digit 2.81, and I have 2 tens. So what does that tell me is my exponent? 2. Good. The exponent matches the number of tens, okay? If you're given expanded form. It also equals the number of digits after your decimal until you reach where the decimal originated, okay? In these other questions, the decimal was hiding. This one, we saw a decimal, so it depended where the decimal started as. All right, the next one, let's do the scientific notation first. If we see a single digit, it is always 0.0. So this guy is 0.0. Then we write our times 10. How many tens do you see? 5. Good. So the exponent is 5. And now what we're going to do is we're literally going to type that in our calculator. Now, in our calculator, there's a fancy button, and it's above, well, it's actually right above your comma. Right above the comma, it says EE. That EE right there, that is your times 10. That's your scientific notation on your calculator. So if I wanted to type that in, I would type in 7 second E, or second comma. It says EE on the calculator, but only one letter E shows up, okay? And when you see the letter E, it's always times 10. Now it wants you to put your exponent number. That's why it says E. So we're going to put our exponent number on that guy was a 5. So now we're going to see what it looks like in expanded form. It's going to show us the answer, okay? So it's going to be a 7 with all 5s, or sorry, a 7 with all 5 zeros. So I have a 7 and 5 zeros. So there's a couple ways you can type it in the calculator. The calculator steps are on the next couple pages, and I'll show you those as well. All right, working backwards again. So they're giving us scientific notation. So now we're going to go to expanded form. Expanded form, I look at my times 10 part. That tells me how many number 10s I need. So 9.2 times 10 squared. This tells me I need 2 number 10s. So I'm going to have 9.2 times 10 twice, because I need 2 number 10s. And now I could type that in, or I could just move my decimal. So I'm going to move my decimal, because that's how I like to do things. I'm going to move it 1, 2 times. You move it the same amount of times as the exponent, or the same number of tens you have. So I have 2 tens. I moved it to the right twice. So my number would start as 920. And you'd have your hiding decimal on the right. Okay, so your decimal will hide on the right always. All right, last one here on this chart. We're going to work backwards again. How many tens will I have to draw? 6 of them. Good. So let's draw our 6 tens. It is. I'll redraw it. It's kind of starting to glitch again. 1, 2, 3, 4, 5. I need one more. Yes, this thing is starting to glitch again. There we go. So now we could type that in the calculator or move our decimal point. So the decimal is behind the behind the 1. So I'm going to move it 6 places to the right. That's going to give me 5 zeros. So I'm going to have a 1, 4, 0, 0, and 3 more zeros. So you're going to have 1,400,000. And now what we're going to do is we're going to put the numbers on the top of the page into scientific notation. That's going to be the filling in the blanks at the bottom here. So Earth to Sun, we've got the number 93, so 93 million. I'm going to put that number up first. Speed of light, we've got 300 million. And then that top number, I've got 1, 2, 3, 4, 5, 6 sets of zeros. So 27. Okay, so those are the numbers we're turning into scientific notation. And again, it's because they've got lots of zeros and it's really big. So when we draw all those numbers, we put our hiding decimal always. Show your hiding decimal so you know where he's located. Now I want to move that decimal. I've got to move it between the 9 and the 3. So now I count how many numbers now are after that decimal to get to the other decimal. So I'm counting the number of spaces between these decimal points now. So I've got 1, 2, 3, 4, 5, 6, 7 spaces between them. So I'm going to have 9.3 times 10 exponent 7. Okay, it's not a 6. Yes, you have 6 zeros, but you've got to move it that extra spot to get rid of that 3 as well. Okay, speed of light. Where am I going to locate my decimal? Where does he have to go to? After the 3, right? So he's going to move right there. So now I count how many spaces between the starting decimal and where he ends up. I've got 8 spaces. There's 8 zeros between. So again, you're not counting zeros, you're counting spaces. So I've got 8 spaces. So I know I'm going to have a times 10 to the 8. What would be my first number? 3.0. Good. We're going to put our decimal in there with scientific notation. You want to show that decimal. So 3.0. Oh, and we're back. Okay, last one on this page. We got to move that decimal on the bottom question between the 2 and the 7. So that's where I'm moving my decimal point. As soon as it shows back up. Come on now. It moved my numbers. Okay, my numbers are really weird now. Okay, so it moved where I put my 2 and my 7. So now I got to count how many spaces are between those 2 decimals. That's what I'm counting. How many spaces are between? Well, I've got 3, 6, 9, 12, 15, 18, 19 spaces. So my answer is going to be 2.7 times 10 to the 19. All right, turn your page. We're going to do a lot of this on the calculator now. After we look at the small digits. So we've converted now large digits. So large numbers, what are you noticing about every single exponent in here? What kind of digit is the exponent?
A number.
Is it natural? Is it whole? Is it integer? Is it rational? What kind of digit is it? It's all of them except for irrational. Okay, so any digit, so all of these exponents are whole numbers. They are digits. This guy, this guy, this guy, they're all positive. Okay, that's the one what I want you to think about right now. Every single one of those are positive exponents. So positive exponents are representing large numbers. Okay, we're going to do the exact opposite on the next page. We're going to look at smaller numbers and then what happens with the exponent. All right. So these ones we're going to convert to expanded form. Again, when you take a look at questions like these, they're always going to give you 2 or 3 examples. They're going to give you an easy, a medium, and then a more challenging one. So if we look at example 3, positive exponent, I have 7. I need to have my number moved 7 times. So I could take my pencil and move my exponent 7 times, or I take my calculator and I type it in. So I'm going to type in 3.8 second E, or second comma, that gives you your E. So it's times 10 to the 7, and then I hit enter, and it's going to solve it for me. So that's going to give me 6 zeros at the end. So I'm going to get an answer of 3, 8, and 6 zeros. So that's 38 million. Okay, the next one. We need to move it 12 places. So if I move it 12 places, first of all, I got to move it 2 places to get rid of that, and then it's going to have zeros at the end. So if I've moved it 2 places, that's 2 out of the 12. How many other places do I have to move it? To make 12 places, if I've already moved it 2, I have to move another 10 to make 12 spaces. So again, I could be just doing this and moving my decimal and putting zeros, or we go to our handy dandy calculator and we type it in, and we're going to go 2.51 second, comma, and now we put in the number 12. And if we count, we are going to have 10 zeros. Okay, you're going to have 10 zeros on this one. Why do you think it's just giving me E12 back? It's too big. That's the reason it's giving me the E12 again. It's not going to show me all those zeros. So you're seeing up here for an E5 times 10 to the 5, it'll show me my zeros. Times 10 to the 7, it's going to show me my zeros. But when you get to a certain point, your calculator's not going to show you all those zeros. It's going to just put it back into scientific notation. So my actual answer for this, you have to understand how many places you're moving it. My answer would be 2, 5, 1, and 10 zeros. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So millions, billions, trillions. So you'd have 2,510,000,000,000. That's what the number is. Okay. C, we're going to do letter C here. We only have to move it 3 places. The smaller numbers are easier to move, so I can literally just move it like this. Every time I move it, I have to put a 0 place value if there's no other digit. So these other spots would become zeros. So now I know this number is 2900. Okay? So I've moved it 3 spots. All right. Now they're giving us numbers, partly in scientific notation, partly not. They want us to figure these out and simplify. All right. They want us to simplify it, then write in scientific notation. So what we have to do is we're just going to literally multiply it all out in our calculators. So I would grab my calculator and I would go 7.1. And you could go times 10 exponent, because you can do that, times 10 exponent 2, enter. About to push play. Thank you. Okay, so we count the number of places between where the decimal should be and the original place. We have to show that it's dividing by 10. So you could show it this way, or you can show it the other way. You could say that you've got 5.3 times 10 to the negative 1 times 10 to the negative 1 times 10 to the negative 1 times 10 to the negative 1. So you can show it both ways. So either dividing by positive 10, because we like to deal with positive exponents, or you could show this, showing that they are negative. And that means that we've moved our decimal the other way. That's all it tells us. So scientific notation will end up being 5.3 times 10. Now, how many negative 1s do we have? 4 of them. So we'll have negative 4. Okay, so that's how that works. Now, do we have to show the over 10s? No, we don't. You can do it either way. I'm going to show the positive exponents on this one, and then I'll do it the other way on the other one. So this guy, I'm going to show the positive exponents because I'm running out of room here. So I would have 7.0 on top of. Now, how many spaces are in between those? I see 8 spaces. So if there's 8 spaces, I'm going to have 8 10s on the bottom. Okay, let me count. 1, 2, 3, 4, 5, 6, 7. One more. 10. And that guy over here does not look like a 10. Okay. So we're going to convert to scientific notation now. We would have 7.0 times 10 to the negative 8, because we had to move it 8 places. So the exponent is always how many places you had to move it from his old location to his new location. So this one, because it's being divided, we can do our scientific right away. 2.9 times 10. And now what's the exponent on my 10 for that one? How many 10s do I see? 3 of them. So what kind of exponent am I going to have? Positive or negative? Negative. You're having a negative exponent because you moved your decimal the other way. Okay? Whenever your original number starts with 0.000 something, that's going to be a small number. So your exponents will always be negative. So all of these are going to start with a 0 point whatever. So this guy says move it left 3 places. So if I have to move, I'm going to just put it up here, 2.9. If I have to move him 3, there's 1, 2, 3. That means these have to be zeros. And you have to start it with a 0. So I'm going to have 0.0029. And your calculators like scientific notation. So a lot of times they won't show you that as standard form. So if I go to my calculator and I try, and I go 2.9 divided by bracket 10 times 10 times 10, let's see what it gives us. It is going to give us all the decimal zeros. Sometimes it won't, depending on how many 10s you've got. I think 7 is the maximum it does. Otherwise, it'll convert to scientific. Okay. So the next one, 7.1, I'm going to move my decimal. Count your 10s. 1, 2, 3, 4, 5, 6. So I'm going to move my decimal place back 6 to the left. So I'm going to go 1, 2, 3, 4, 5, 6. But my decimal goes there. If your decimal goes there, all these other places become zeros. And then you have to start your number with a 0. You can't just start with a decimal. So this guy's going to be 0. Point. Now you're going to have 5 zeros. 1, 2, 3, 4, 5, and then a 7 and a 1. So that's what your original number looks like. Now we're going to go to scientific notation. 7.1 times 10. And now we counted our 10s on the bottom, and we had 6 of them. So negative 6. And again, if you wanted to, you could have showed it like this. You could have showed the times 10 to all of the negatives. Okay, you could have showed that instead of showing the dividing by. Both are correct. But you will see it both ways. Okay, next question. So 3.1, we're moving it 3 places to the left. So I'm going to go to the left first. 1, 2, 3. So there's my decimal. I would have a 0 there, and a 0 in front. So I'm going to have 0.0031. So now, this is where they put the decimal. How many spaces are between them? 2 zeros and a 3. So I've got 3 spaces in between where the decimals are, right? Because this is where they ended up putting the decimal. So I want to look and see, that's where it started to where it ended. How many numbers are between them? I have 3 numbers between them. That means I'm going to have 3 10s on the bottom. So on the bottom, I'm going to have 3 10s. And then on the top, I'll have my 3 decimal 1. Okay? I'm going to give you maybe 2 minutes. I want you to do the very last one, and we'll see how you do. I'll put the answer up in a moment. So the first thing we're going to do is we're going to look at the right. We're going to find our decimal, and because it's negative, I'm going to move that decimal to the left. So I'm going to go 1, 2, 3, 4, 5. Put my decimal. All those places now have to have zeros. A 0 in front, and all those other spaces need to become zeros. That's how I create my original number. So my original number started as, I'm going to have 4 zeros now. and then an 8 and a 5. So now I take a look, how many places did I have to move it? Well, first of all, if it's in scientific notation, that -5 is telling us how many 10s we need on the bottom. So how many 10s do we need on the bottom? 5 of them. Good. So when I draw this, I'm going to have 10 5s on the bottom. And on top, I'm going to have my 8.5. All right. Turn your page. Hopefully you got the same answer. So top of the next foot, it says, or next page, it says an inch is about how many kilometers? Well, that was the number they told us on the first page. So that was the number we put into scientific notation. So we had the number 0.000254. Now I want to put that into scientific notation. How am I going to put that number into scientific notation? Where does my new exponent go? Okay.
And then the times 10 to the exponent -4.
Exactly. Well done. So it's a negative because my number is very small and it starts with a 0 point something. Whenever your numbers start with 0 point something. Okay. It says the mass of a particle of dust is about how many kilograms? Well, we had a number with 0.9 So this is the number we have. 0.123, 1, 2, 3, 1, 2, 3, and then the number 75. So that's our original number. That's our particle of dust. So my decimal's on the left. I need to move my decimal where? My decimal needs to move as soon as it comes back. Come on back. Oh, I'm going to have to zoom out. Oh, it came. Okay, good. Okay, so I need to put my original decimal or my new decimal between the 7 and the 5. That's where it's going to go. So I know I'm going to have 7.5 times 10, and now I got to count how many spaces are between those two decimals. And I've got 10 spaces between them. So that means my number is going to be a -10. Again, it's negative because my number starts with a 0. Okay. The mass of an electron. Okay, our electron. This one is huge, and I'm not going to draw it all. It showed it on the previous page in the previous lesson. There are 28 zeros. 27 zeros. So this number is like this. It goes 0 point, and then you've got 27 zeros. And yeah, 27 of them, and then the number 9. So we would have to move our decimal right here. So how many spaces are between then? I would have 27 and then the extra 1. So how many places did it move? 28. So I would have 9.0 times 10 to the -28. Deshane's dancing next door.
Could you?
So it says, explain why 0.4 times 10 to the -8 is not written in scientific notation. What is wrong with this first number? What's going on with this? It starts with a 0. Is it allowed to start with 0? No, it's got to start with a number 9 to 1. So anything between 1 or 9. So that means I need to move my decimal to the right once. Now, if I'm moving my decimal to the right, that means it's going to be another negative space. So I'm going to add another negative to that. So it's going to end up as 4.0 times 10 to the -9. Because I had to move it one more place. Okay, so it's times 10 to the -9. That's what it should look like. Now I'm going to show you how to do it on your calculators. So we see the EE mode, okay? But now we're going to actually change modes on the calculator. So grab your calculator. Right beside the blue second button is the mode button. So hit mode, please. At the top, it should say Math Print Classic, or it might just say normal, SCI, that's scientific notation. So we're going to use our right arrow and make scientific notation, SCI. We're going to make that selected. So you want it to blink. So you want it to blink and then hit enter. That means you've selected it. So now I'm in scientific notation. Okay. So the ENG, that's for engineering. That's if you go to university and continue with math and go into engineering. There's an engineering part where it'll convert stuff for you, so it's not longhand. So in scientific notation, now we're going to go back to quit. If you want to go back to your main screen, you can either hit second mode. Second mode is your quit. It just goes back to your main screen, okay? But now we're in scientific notation. So now we're going to type in the number. We're going to type in the number that we see for the sun. We're going to type in 4506, and then we've got 6 zeros. 1, 2, 3. Okay, type that sucker in your calculator. It's on the middle of page 87. And now that you're in scientific notation, hit enter. And it's going to have it for you. So it's going to have all the digits. It cuts all the zeros off the ends, just so you know. It has to show digits that are digits other than zeros. The zeros will get cut off the end unless they're in between digits. Then they're going to show you E9. The positive exponent here, everyone, that positive exponent tells us it was a large number. If it was a negative exponent, that tells us it's a small number, like a particle of dust or a piece of bacteria or something. Okay, so that's a large number being converted. Now what we're going to do is we're going to turn the page, and I showed you how to use the EE feature. We're going to go to the very bottom of the next page. So we've done this. We're going to go back. Before we do that, though, we're going to change our calculators back out of scientific notation. So we're just going to go back to normal mode. So that means you're going to hit your mode button where it says flashing. Oh, it's frozen on you. Hang on. So when you select it, it turns the black color. So I'm going to hit enter, and now I'm selected back to normal. So now I'm going to hit either clear or second mode. If I hit clear, I go back to my main screen. So does second mode. Second mode is quit. Okay, so now we're going to type in the number. We're on the bottom of page 88. So the bottom of page 88, we're going to type in these numbers with EE. So we're going to convert them, but that's big numbers. So whenever we've got scientific notation, we need to use brackets. So they're showing us brackets on purpose here. So when I enter the information, I'm going to use brackets, hit my time sign, use brackets, and then hit enter. Same thing with a fraction. When it's in fraction form, meaning dividing, that's what dividing means. It's fraction form. Again, you need brackets, but they're not showing it. So you would use brackets and then hit enter. So all of us, we're going to try both of those equations, both of you, or both of those. I'm going to give you a couple minutes. I want you to give it a try on your calculators, and then I'll put the answer up. Okay, I showed the solutions on the calculator right here for you, so you can take a look at what happened there. So you're multiplying, you're using that E feature. That E feature is your second comma. Okay, back to our workbook. We're going to write the answers in, and this is the end of scientific notation. You've got the rest of the block to work on your practice questions. Tomorrow, we're going to zoom through lessons 12 and 13. That's the end of our unit. Unit quiz is Monday, exam on Wednesday. So the answer will be 9.1 times 10 to the 14. Now, can you write it like this? Are you allowed to write it like this as an answer? 9.1 E 14. Are you allowed to show me that? No, you have to show me the times 10. Okay, this is what shows on the calculator. Okay, that's the calculator. You need to show me this part, okay, when you're writing it. Okay, the answer to the last one was 1.5 times 10, and it was a negative number, -8.